So the first one here that we have is bias. It's sampling bias. So if the results of the sample are not representative of the population, then the sample has bias, meaning that we didn't use all the individuals from population. We may have used something else. So here we're going to explain more. Sampling bias means that technique used to obtain individuals to be in the sample tends to favor one part of population over another one. For example, I can say we try to find the average score in our college for all the classes that they have right now in summer. But as a sample, when we try to choose our individuals, we only had our sample from, for example, math courses, not the other classes, just math courses. We randomly selected some individuals from, for example, this class, and we ignored what we had in, for example, history or other classes. That is sampling bias. So meaning that we favored the part of the students that were in math class and didn't consider the other students that were in other classes. So favor one part of population or other. On this part, we have under coverage. This is when the proportion, or that means that we have to use division. So the proportion of one segment of the population is lower in sample than it is in population. On this part, when we have under coverage, that means that we have incorrect or incomplete frames. What frame is our population. And that can lead to under coverage. Example, the village of Oak Lawn wishes to conduct a study regarding the income level of households within the village. Village manager selects 10 homes, and that is in southwest corner of village. And sends an interviewer to the homes to determine household income. But in the first line, I see that this is in the village of Oak Lawn. But here, when we're finding sample, just selecting sample, they work based on what they had in southwest corner of village, and that's it, and ignored all other individuals in that population. So this is our population. And they have to select this 10 homes from all parts, not only focus on one part of population. This means instead of this one, they considered this part of village as population, which is wrong. So we call that poor frame. Because this is not the population that we have to use. non-response bias exists when individuals selected to be in the sample who do not respond to the survey have different opinions from those who do. Yeah, so we may have survey, but asking, for example, 10 people to answer those questions, but out of 10, we only had, let's say, that I had 7 responses and 3 didn't respond. So that is non-response bias. We cannot have conclusion based on 7 because 3 are missing. In this case, we have non-response bias, and how we can improve that. Non-response bias, non-response can be improved through the use of callbacks or rewards incentives. So we can have rewards for that. We may say, okay, if you complete this survey, you will receive $1. Okay, here, this one, for example, the data is for non-response. Here, considering opening a new store. Before opening the store, the company would like to know the percentage of households in Oakland that regularly visit an ice cream shop. The market researcher obtains a list of households and randomly selects 150 of them. So randomly selected 150. He mails a questionnaire to 150 households, asks about ice cream eating habit and flavor. Of 150, 4 are returned. That's the worst result they can have, because out of 150 samples that they tried to have answer for that, so based on 150, they were able to have conclusion for the population. Is just estimation. So whenever you're using inferential stat, that is estimation. It's not exact answer for population. But the point is here, they didn't receive any answers for 146. They only had 4. So based on 4, they're not able to have conclusion and decide based on the result for that survey. So all surveys will suffer from non-response. So in this case, they were able to have better result by just having a reward with something else. They may be able to let them know that if you complete that survey, you will be able to have free ice cream for $5. Maybe $5 is too much. Anyways, all surveys will suffer from non-response. The federal government's current population survey has a response rate of 92%, but it varies depending on the age of individual. For example, the response rate for 20 to 29 years old is 85, and for individuals 70 and older is 99%. So in this case, for 70 and older, which is 99%, that is better result. So when they're trying to have their conclusion, they can make sure that their answer at the end is very close to what they expected here in survey. Mm. 85% is not that bad. It's better to have 100% if it's possible. For example, in this case, 150 was our sample. If we had very close to 150 response, that is better. Now, next page is response bias. Exists when the answers on survey do not reflect the true feelings of the respondent. Here we have a type of a response bias. You may ask you may ask individuals to complete survey, but you cannot trust their answers. That is response bias. So for several reasons, you may not only depend on what their answers were on that survey to be able to decide what the conclusion is. So one of these is interviewer error. So trained interviewer is essential to obtain accurate information from survey. Skilled interviewer can elicit respondents from individuals and make interviewee feel comfortable. So if interviewer were not able to have good communication with interviewee, so the other person may think that it's better to not be honest, or the way that he answered the questions is not what actually he wanted to. So we're not able to trust that survey. For example, here the question, the type of question that he's asking, that is important. Have you ever cheated on your taxes? Obviously, if you ask someone this question, even if they did, they're not going to answer yes, I cheated not part. So they're not going to answer that way. So do not be quick to trust surveys. Do not trust survey results if the sponsor has a vested interest in the results of survey. Here we have another question here. Would you trust a survey conducted by a car dealer that reports 90% of customers say they would buy another car from the dealer? Are you going to trust that one and go to that dealership and buy your car from that dealer? This is when you going to dealer and they have survey and asking customers, are you going to buy another car from us? You're gonna say yes, absolutely, I'll buy another one. But what is your action later? That is important. So we cannot trust this one. Misrepresented answers. Next one, number 2. Some survey questions result in responses that misrepresent facts or are flat out lies. Here we have example. For example, survey of recent college graduates may find that self-reported salaries are inflated. Also, people may overestimate their abilities. For example, ask people how many push-ups they can do in 1 minute. For example, here, you can say here at college, we may ask students how you feel about your courses. You think that are you doing well in this class, for example? The student may say, yeah, I'm doing great, and I'm able to solve all the problems. I'm the best student, like that. Or also, we may ask faculty members how you feel. Do you think that your teaching style is the best one, or you have to do something else to improve your teaching styles? That faculty may say, no, I don't need to do anything else to improve my skills. And I feel that I'm the best faculty member in this college, right? So we cannot trust these. That's misrepresented answers. Number 3, words used in survey question. The way the question is worded, that is very important. For example, if someone asks, do you believe in trampling women's rights and oppose abortion? Is this a balanced way to ask whether or not someone supports or opposes abortion? So some may say no. So the way that we word our questions, that's very important. Okay, what else? And order of questions are also very important. For example, we have candidates in political race by presenting question in different order to each respondent. Okay, I can't see what the question was. Okay, by presenting question in a different order to each respondent, one ensures that each question gets asked in the same context as every other question, the same number of times, first, last, or any position in between. So here in this case, order matters. For example, we may have 2-3 questions about, let me see if I can find something. For example, we had a new ice cream shop in our city, and someone trying to have survey. For example, the first, second, and third one. They may ask if you like the ice cream flavors, but later asking if, are you aware that we had a new ice cream shop opened? And let's focus on these two. So the order, how we can have the first one asking about if you like the flavors of that ice cream shop, and then ask them, okay, did you already know that they had a new one open, new shop open in our town or not? So it's better to have this number 2 first and then having number 1. So that someone may say, okay, no, the answer for this one, no. So how they may answer that part? They may just say, yeah, I like the taste of ice cream. But later you see that, oh, the answer for that one was no. So what is this result? That is wrong. Type of questions. One of the first considerations in designing a question is determining whether the question should be open or closed. What open and closed means, so open question is when you only have a question asking what the answer is, they can answer anything that they think is the best answer for that question. But for closed questions, we may have multiple choice. So what is the most pressing student issue that MJC should address in its next annual plan? These are multiple choice. So you only can pick from these for your answer, not something else. You may say, okay, my answer is not here. I'm not able to answer this question, and this is not good. So for the first one, open question, this is harder to analyze. It's easy for individuals to answer. So harder to analyze if we had different responses. I may say, okay, for example, for that one, we may have like 20 different answers, so that way it's hard to analyze. And closed question, we have limited choices. but this one is easier to analyze because we're working based on these 6 answers. Next page is sampling error versus non-sampling error. Non-sampling errors can, these are errors that result from sampling bias, non-response bias, response bias, or data entry error. So we already had these. Sampling error is error that results from using sample to estimate information about population. What that one is, this is exactly what we did for inferential stat. Okay, let me have example for that for first non-sampling errors. For example, such errors could also be present in an incomplete census of a population. These errors can be limited, but hard to ensure that none will occur. So, for example, this one, what if we had survey, but there are homeless people that they're not able to complete that survey. So we selected to have our survey from 10 households. But our population was, for example, Modesto or Trolley. But we should consider all the population, not only those that have house. What about homeless people? So this is non-responses of homeless people, that is non-sampling errors. Now, sampling error in sections before this one, we said by having a random sample of individuals from population and working on that one to find the answer. Based on that, we can extend the result from sample to population to decide what the answer is for all the individuals in the population. That was inferential stat, but that is sampling error. We cannot say whatever the answer was for sample, we're going to have exactly the same answer for population. We will not have same answer for population because we have different number of individuals in a population. It's not only what we have in sample. That's only estimation. It's not correct answer that we can refer to have our conclusion. So this type of error occurs when because a sample gives incomplete information about population. The sample gives incomplete information about population. There will always be some sample error, since a sample can never truly represent its population exactly when there is variation. So it's not exactly, that is only estimation. So in this case, later you're going to see that we are going to work on finding margin of error. And we are going to subtract and add to find the result. That is E. So we will have that later. Example, the following surveys have bias. Determine the type of bias, suggest a remedy. Part A, retail store manager wants to conduct a study regarding shopping habits of his customers. Okay, so he selects the first 60 customers who enter his store on Saturday morning. Since instead of for example, Saturday, the population was Saturday morning, so this one is poor frame. And here we have under coverage. So here on this part A, we had the first 60 customers that are entering that store. So that is not a good idea to have our conclusion based on only these individuals. And also here we see that it just focusing on Saturday morning as a population. The main part is this one. And they can have, instead of this poor frame, we can have a complete frame is, again, frame is what our population should be. So a complete frame is not because we don't have any other information on that part. I'm not able to see what is our population. It just say his customers. We can say all his customers, but it's not possible to find out what is population. So it's better to use systematic sampling in this case. Now part B. Here we want to estimate the percentage of people who favor stricter gun laws. He conducts a nationwide survey of 1,203. So that is our sample, randomly selected adults 18 years old and older. The interviewer asked the respondents, do you favor harsher penalties for individuals who sell guns illegally? So this one is response bias, and the question is poorly worded. It's better to ask that question in different words. It's simple to write this in other words. Then instead of do you favor, we can say do you approve or disapprove. The only part I changed was this one. Instead of do you favor, I had do you approve or disapprove. Now part C. Asking those that their primary language is foreign language, and that survey maybe is in English and they didn't understand, so they were not able to read the questions. That's why they didn't reply. That is the reason. So this one is non-response. And we said they may not be able to answer the questions because of having a different language. So instead, they can have phone call and having interpreter or translator. So phone, interview using their own language and also speaking English together. So meaning that they are going to have interpreter. Or face-to-face. Do you believe marriage can survive when your husband destroys? So it's not nice to have this question like that. So the husband destroys the trust that must exist between husband and wife. So this is poorly worded. And you can answer this different way. So do you believe a marriage can be maintained? Not just saying, okay, when the husband destroys the trust, we shouldn't have our question that way. Now, next page, consider the following two questions. This one is asking if order matters. So here again, we have response bias, and for response bias, we had all these four. And the one that is on that page is asking if order matters. So it's number 4. If order matters. So suppose that the rape is committed in which the woman becomes pregnant. Do you think the criminal should or should not face additional charges if the woman becomes pregnant? So that is the first question. And the second question is, do you think abortion should be legal under any circumstances, legal under certain circumstances, or legal in all? So here it's asking, do you think the order in which the questions are asked will affect the survey results? The answer is yes. So it matters which one comes first. If the answer for part B, if this one was legal, the answer will change for part A. So it's better to have B first and then part A. Change the order. Number 3, many polls use random digit dialing. So it's RDD for random digit dialing to obtain a sample, which means the computer randomly generates phone numbers of landlines. What is the frame for this type of sampling? So it's asking, what is our population? Or our population is anyone who has phone. And you may say any household without phone, or we may say on the do not call. They may have this option. So on do not call. They may have locked, for example, the number. Or homeless people, so that don't have access to a phone. So all these are excluded. And okay, how might this affect? So because of all these that are excluded from our sample, we are going to have sampling bias. That is because under coverage, we preferred one part of the population over the other one. So we didn't consider all the individuals that we have in the population. You may say our population was anyone who had a phone, but here we have homeless individuals are excluded. They may have their phone number before, but suddenly they may have lost their home. That's why we can also have this part here. So we can just skip that one. That's fine. Okay, I'm just writing this one this way. So this is better answer for this part. So this could result in sampling bias due to the undercoverage, because we prefer the one part of the population over another one. We only consider those that have a phone, access to a phone. But what if we had these people here homeless? So due to the undercoverage, if the excluded people differ from those included in the frame, suppose that a radio station predicted that candidate would defeat candidate B, A would defeat candidate B in certain election. They conduct a poll of automobile owners with a response rate of 23% on the basis of the results. The radio station predicted the candidate A would win with 57% of the popular vote. However, candidate B won the election with 62%. So for A was 57, but for B we have 62% of the popular vote. At the time of this poll, most automobile owners belonged to the party of candidate A. Name two biases that led to this incorrect prediction. So the result was 57% for A, but 62% for B, but they actually belong to candidate A. We had that the radio station predicted, their prediction was that candidate A would win 57% and candidate B would win 62%. That was prediction. But at the end, what they had, they saw that, oh no, something else. We have, instead of B, we have candidate A. Most of automobiles owners belong to candidate A, not B. So why we had, for A, we had 57%, and for B, we had 62%. So we expect to have candidate B, not A, but we have this one. In this case, I may say non-response bias, because not everyone answered the questions that they had on survey. This was their prediction, but on survey, they selected this one. Here in this case, we may ask how many responded. And we know that the response rate is 23%. That is very low rate. And also we may ask who they picked to answer the questions. They conducted a poll of automobile owners. So that is our population. We have to select our sample group from those owners. So our answer is A, because of having incorrect frame and also because of having low response rate. In the state of California, speed limits are established through traffic engineering surveys. One spread of the surveys for city officials to measure the speed of vehicles on a particular road. Can you answer this one? What is the population of interest for the for this portion of engineering survey? Here we want to they want to measure the speed of vehicles on a particular road. You only need to add all, right? So all vehicles that are in that particular road. Now part B, what is the variable of interest for this portion of engineering survey? Is the variable qualitative or quantitative? Quantitative, because we have a number for that one. So if we are able to measure speed, that means that we are able to say what is their speed. So that means we are able to count. So this is quantitative. What is the level of measurement for the variable? We have ratio as our level of measurement. Can we have zero as a starting point? Can we have zero speed? Just stop. We can say, okay, their speed is just zero. We can use zero here. And this is feasible in this situation. Explain why or why not. That means, are you able to count how many cars are in that particular road? We're not able to say how many vehicles are using that particular road, for example, daily. So this one is impossible. To count how many vehicles are going to use that road or will use that road in the future, or since so we cannot obtain a list of every single vehicle. So since this is impossible, since one could not obtain a list of every single vehicle that use or will use the road. Now part F, is a sample feasible in this situation? If so, explain what type of sampling plan could be used. If not, explain why not. That whenever you didn't have complete frame, you have to use systematic sampling. It's asking, is this sample visible in this situation? Yes. If so, explain what type of sampling plan could be used as systematic. Sample, and that is because we don't have complete frame. Other sampling methods, all of those depends on if you have complete frame or not. Not having complete frame, you're not able to use the other 3 methods. So the residents actually favored the lower speed limit. So they had a decision to increase speed limit. What kind of bias we have? So explain how bias might be playing a role. Do we have good frame? For example, I may say, what if they selected individuals, for example, from another city? Because here it says city residents actually favored the lower speed limit. So if they had their survey from that part of city, they should have a different result. They shouldn't have this decision to increase the speed limit. So the point is that their decision was to increase the speed limit from 40 to 45. But later we see that city residents actually favor the lower speed limit. So how this one is possible? How they can increase when they favor lower speed limit? They may have asked other people, not these residents. So using city resident as a sample. But first we should know what is our population, what is a good frame. And based on that, what our sample should be. Using, so this one is related to this part here, using this particular road. And we try to measure the speed of vehicles on that particular road, and they want to make a decision if they should increase the speed limit or not. And what they may have done is that they may have selected their sample from just part of the population. Not, they may not have considered the all the individuals that they have in the population, meaning that all the vehicles that are in the road. There may be some individuals in that sample that not even driving on that road. That is another reason. Yeah, may not even use that road. That's why we're gonna have sampling bias.